Okay, Wildcat. So in activity 4.3, extracting roots to rewrite radicals. You can extract roots to rewrite radicals using radicals or powers. Go ahead and look over the worked example. Go ahead and mark out 1 and 2. Let's take a look at the next page. 3. Method 1 and Method 2 each extract roots and rewrite the radicals square root of x squared y squared. Go ahead and look over Method 1 and Method 2. Who is correct? Method 1 and Method 2 are correct. Well, let's take a look at number 4. Rewrite each radical involving a quotient. 4a. So, when you take the square root of a fraction, you can take the square root of the numerator and the denominator separate. So, this is, by the way, the second root. It's the same thing as square root. So, we're going to take the second root of m to the fourth divided by the second root of n to the sixth equals, which can be rewritten as m to the fourth divided by 2 divided by n to the sixth divided by 2, which simplifies to be m squared divided by n cubed. Let's take a look at 4b. All right, so we have the cube root of j12 divided by the cube root of k cubed, which can be written as j to the 12 divided by 3 divided by k to the third power divided by 3, which equals j to the fourth power divided by k to the first power. All right, go ahead and finish up 4a and 4b. All right, let's take a look at the next page. For some radicals, you may not be able to extract the entire radical. Method 5. Method 1 and Method 2 extracted the roots from cube root of 16x to the 8th. Go ahead and look over Method 1 and Method 2. Mark out A and B. The teacher will work 6a through 6h on separate pages. 6 says rewrite each radical by extracting all possible roots. Write the final answer in radical form. All right, let's go and take a look at 6a. We have the square root, which is also known as the second root. We can rewrite this as the second root of 16 times the second root of x to the sixth equals, let's go ahead and do the second root of 16, which is 4, times, this can be rewritten as x to the sixth divided by 2, which simplifies to be 4 times x cubed. All right, go ahead and finish up 6a. Let's take a look at 6b. All right, square root can be written as the second root. So that's negative times the square root of, now, we can't take the square root of 8, but what we can do is separate 8 with the perfect square. So we want to see if a perfect square goes into 8. So let's take 8 divided by 1. That doesn't really matter. 8 divided by 4 is 2. So we can rewrite 8 as 4 times 2. Okay, so that's 4 times 2 times the second root of, and we can actually write v cubed as v squared times v. Okay, so now we have negative second root of 4 times the second root of 2 times the second root of v squared times the second root of v, which the second root of 4 is 2, so that's negative 2 times the second root of 2. Now we can rewrite this as v squared divided by 2, and we can rewrite this as v to the, technically that's 1 divided by 2. So then that's negative 2. The second root of 2, we can just leave it as the square root of 2. V to the 2 divided by 2 is v to the 1 power. And v to the 1/2 power can just be rewritten as 2 square roots of v to the 1. So then we have negative 2 times v times the square root of 2 times the square root of v. Which, since either both square rooted, we can put them together. So then this simplifies to be negative 2v times the square root of 2v. All right, go ahead and finish up 6v. All right, let's take a look at the next page. C. So remember, this is the second root. So that's the second root. We can rewrite d cubed as d squared times d times the second root. We can rewrite f. We actually just leave it as f to the 4th. Okay. So this can be rewritten as, technically that's a 1. So d to the 2 divided by 2 times d to the 1 divided by 2 times f to the 4 divided by 2. So that d to the 2 divided by 2 is d to the 1, which is just d, times d to the 1/2 times f to the 4 divided by 2 is f squared. So this can be rewritten as d times f squared times d to the 1/2, which d to the 1/2 can be rewritten as the square root, so times the square root of d. All right, go ahead and finish up 6c. Let's take a look at the next page. All right, 6d. So remember, that's the second root. So this can be rewritten as the second root of h to the 4th times the second root of j to the 6th, which can be rewritten as h to the 4th divided by 2 times j to the 6th divided by 2, which simplifies to be h squared times j to the 3rd power. All right, go ahead and finish up 6d. All right, 6e. Remember, this is the second root. So that's the second root of 25 times the second root of a squared times the second root of b to the 8th times the second root of c to the 10th. Okay, well, let's find out what the second root of 25 is. It is 5. So that's 5 times a to the 2 divided by 2, b to the 8 divided by 2, c times 10 divided by 2, which equals 5a, b to the 4th, c to the 5th. All right, go ahead and finish up 6e. Let's take a look at 6f. So that can be rewritten as the fourth root of 81 times the fourth root of x to the 4th times x times the fourth root of y to the 12th. Okay, so fourth root of 81, let's find out what that is. Is 3. So 3 times x to the 4 divided by 4 times x to the technically a 1, so 1 divided by 4 times y to the 12th divided by 4 equals 3x. X to the 1/4 can be rewritten as the fourth root of x to the 1 power, and then y 12 divided by 4 is y cubed. So this simplifies to be 3x times y cubed times the fourth root of x. All right, go ahead and finish up 6f. All right. 6g can be rewritten as x plus 3 to the 9 divided by 3 power, which equals x plus 3 to the 3rd power. All right, go ahead and finish up 6g. All right, last one. 6h. Technically, square root is second root, so this can be rewritten as x plus 3 to the 2nd power divided by 2, which simplifies to be x plus 3 to the 1 power, which we can just write as x plus 3. All right, go ahead and finish up 6-8 and the rest of your notes, and have a wonderful Wildcat day.